Welcome, folks. In today's lesson, we're going to be talking about two things. First thing is we're going to talk about, I want to have you guys fill in on your unit circle all the tangent values. I think that'll be useful, especially for what we're doing with the second part of the lesson, which is going to be solving some trigonometric equations. Okay, so just a reminder that if you take any point that's on the unit circle, so any value along the edge here, the sine of the angle at which that point appears on the unit circle will give you the y-coordinate. The cosine of that angle will give you the x-coordinate. And then the tangent of that angle will be the y-coordinate divided by the x-coordinate. Okay, and that's what we're going to be focusing on to begin with, is calculating these tangent values. So if we look at our unit circle, we're going to start by calculating the tangent of this point at 1, 0. And again, our formula is y divided by x. So we're going to take that y-coordinate, 0, divide by 1. 0 divided by 1 is 0. So that means that the tangent at 0 degrees is 0. And then it's a very similar result if we look at the point at 180. So the tangent of 180 degrees is also 0 because 0 divided by -1 is 0. Okay, next we're going to look at 30 degrees. We can see here that our x and y values are square root of 3 over 2 and 1/2. And we're going to use those values to calculate the tangent at 30 degrees. So we're going to say 1/2 divided by square root of 3 over 2. Whenever you're dividing two fractions like this, I think the best way to divide them is to rewrite it so that we are multiplying the fraction in the denominator by the reciprocal of the fraction in the denominator. So it'll look kind of like this. We have the fraction in the denominator times the reciprocal of the fraction that was in the numerator. So I just flipped that fraction. The 2's are going to cancel out. That will leave us with 1 over the square root of 3. We'll multiply top and bottom by the square root of 3 because we don't want to leave radicals in the denominator. And that will give us square root of 3 over 3. And so then what that means is the tangent of 30 degrees is the square root of 3 over 3. Now there's 3 other spots on the unit circle with very similar x and y values: 150 degrees, 210 degrees, and 330 degrees. So we're just going to go through and fill up for them as well. You can see if you have one negative and one positive, your final tangent result will end up being negative. So this one's just negative square root of 3 over 3. You can kind of see the work for that up at the top of the screen here. If they're both negative, then your final result will be positive. So this one will be positive square root of 3 over 3 and negative square root of 3 over 3, because only one of those values is negative at 330 degrees. Okay. Let's move on to 45 degrees. So that's going to be square root of 2 over 2 divided by square root of 2 over 2. That's going to equal square root of 2 over 2 times 2 over the square root of 2. So I'm taking my numerator and multiplying by the reciprocal of my denominator. The 2's are going to cancel out, but so are the square root of 2's. Those are also going to cancel out. So that's really just going to leave us with 1. And so the tangent of 45 degrees equals 1. Again, we're just going to go around the unit circle and fill in all the ones that are very similar to this. So you can see if one of your values is negative, then you'll end up with -1. If both of your values are negative at 225 degrees, that'll be +1. And again, if only one of them is negative, you'll at 315 degrees, you'll get -1. Okay, next up we'll do 60 degrees. And so here we have 1/2 for x and square root of 3 over 2 for y. So we're going to take this as the square root of 3 over 2 divided by 1/2. So that's the same thing as the square root of 3 over 2 times 2 over 1. The 2's will cancel out. We'll be left with the square root of 3 divided by 1, which is just the square root of 3. So the tangent of 60 degrees will end up being square root of 3. And then we can go in around the unit circle and look for points that have similar x and y values. So for example, at 120 degrees, we'll end up at negative square root of 3. 240 degrees, the tangent will be positive square root of 3. And at 300 degrees, the tangent will be negative square root of 3. Okay, and then last we're going to look at the points at the top and bottom of the unit circle. So at this point, 90 degrees, our x value is 0, our y value is 1. So we're going to do 1 divided by 0. Remember that you're not allowed to divide by 0 in algebra. That is undefined, so we can say that this point is undefined. And we'll be able to say the same thing at 270 degrees. That one is also undefined. Okay. So now let's use our completed unit circle to solve a couple of problems where we are solving trig equations. So here I've got 9 different examples. We'll start with this one in the top left here. We'll say when the sine of theta equals 1/2 and the cosine of theta equals the square root of 3 over 2, what would the value of theta be? Well, we will use the fact that sine is the y value and cosine is the x value. So we're looking for a y value of 1/2 and an x value of square root of 3 over 2. So we can see here we have y values of 1/2 at 150 and 30 degrees. Here we have x values of square root of 3 over 2 at 30 degrees and 330 degrees. And so then if we overlap them, we can see that the only point that will satisfy both equations is this point right here at 30 degrees. And so then we'll say that theta equals 30 degrees. You could also do this in radians. I don't really do that in this video, but you could say pi over 6 if you wanted to instead, because pi over 6 is the same thing as 30 degrees. Okay. All right, so next let's do it for when sine is square root of 2 over 2 and cosine is negative square root of 2 over 2. So we're looking for when our y values are square root of 2 over 2. And we're looking for when our x values are negative square root of 2 over 2. And so then when we put them together, we can see that this right here is going to be our point at 135 degrees, or if you were doing this in radians, 3 pi over 4. So 135 degrees. Okay. Next, let's look for when the sine is 0 and the cosine is -1. So here's when our y values are 0. There's really only one spot where our x value is -1, so we could really solve this one just based on that. That being said, when we put them together, we can see that the one that we're looking for is 180 degrees, or pi. So then our answer is 180 degrees. Okay. Now let's do it some problems with sine and tangent. So now my sine is 1/2 and my tangent is negative square root of 3 over 3. So I'm looking for when my y values are 1/2, and I'm looking for when my tangent values are negative square root of 3 over 3. And so then when we put them together, we can see that our answer is going to be 150, because that's when the tangent is negative square root of 3 over 3, and the y value is 1/2. Right? And again, you could do this in radians if you wanted to, so you could say 5 pi over 6. Okay. Now let's do sine is 1 and tangent is undefined. Sine is 1 is right here. Tangent is undefined at these two. So we can tell that this top one, 90 degrees or pi over 2, is our answer. So we'll say theta equals 90 degrees. Next we'll do sine of theta equals negative square root of 2 over 2, and tangent of theta equals negative 1. So negative square root of 2 over 2 is our y value. And negative 1 is our tangent value. And so we can tell that we want this degree measure at 315 or 7 pi over 4 degrees. So we'll say 315 degrees or 7 pi over 4 radians. Okay, now we'll do a couple of examples of cosine and tangent. So remember, cosine is your x value. So for this first one, we're looking for a cosine of 1/2, and we're looking for a tangent of negative root 3. Cosine is 1/2 here. Tangent is negative root 3 at these two places. And so you can see that our answer for this one is going to be 300 degrees. And again, we could do this in radians if we wanted to, so 5 pi over 3. Okay. Cosine of theta equals negative square root of 2 over 2. Tangent of theta equals 1. So we're looking for x values of negative root 2 over 2 and tangent values of 1. So here are where the x values are negative root 2 over 2. Here are where the tangent values are 1. And so you can see that we're going to want this degree measure of 225 degrees or 5 pi over 4. Last up, we're looking for where the cosine is 1 and the tangent is 0. So we can see here the cosine is 1. Here the tangent is 0. And so our answer is going to be the one place where those are both satisfied at 0 degrees. So the answer is 0 degrees or 0 radians. Okay, hopefully this makes sense. Let me know if you have any questions. I think it's worth noting that Desmos is not going to be super useful at this point in time. I can kind of show you why. Let's start with one where it would work, and then we'll show one where it won't work, and we'll talk about why that is. Okay, let's do this one right here. So sine of theta equals 1/2. So what I could do is there is a function called sine inverse. So I could do sine inverse of 1/2. And then if I make sure that I'm in degrees, that will tell me that that's 30 degrees. Well, what's the problem? That's my answer, right? I wanted the answer to be 30 degrees, right? So I could have just typed in sine inverse of 1/2 and gotten 30 degrees. But the problem is at 150 degrees, sine is also equal to 1/2. Well, why didn't it tell me that it was 150? Well, when you're working with the sine inverse function, remember what makes a function a function is that it only has a single output. So it can't tell you that sine has an output of 30 and an output of 150. It's only allowed to tell you one output. And so for that reason, they've sort of defined sine to be in between negative 90 and positive 90. When they do sine inverse, those are the possible outputs. You can get something in between negative 90 and positive 90. And so, sorry, this is kind of a long explanation, but essentially, Desmos is not going to be a super useful tool when you're solving these trig equations, because you won't know. It will only tell you one output, even though for each degree measure, there's actually two possible outputs. You'll want to use the method that I showed you in this video with the unit circle instead. Okay, let me know if you have any questions.